Cohn from Advanced Tubular Technologies. I'm the developer of software called VTube-LASER and VTube-STEP, and this software allows us to measure with a variety of measuring centers in order to measure and qualify tube shapes. And in this case, I've got an exhaust pipe up that I'm showing that has data that's aligned on top of the master. The pink is the measured aligned, and we have tolerance envelopes, which are the transparent cylinders. You can see where it comes out of the tolerance envelope, and over here you see how far it comes outside the tolerance envelope. And we also have the VTube-STEP software. I'm going to click here to switch to step mode. And in step mode, what you can do is you can import a solid model, and the solid model is represented by this yellow model here, and then you can collect features, like in this case the cylinder straights, and then calculate a parametric tube like this and put the data here and send it out to the bender. So what I would like to do today is demonstrate how to connect to a Unison bender using the Unibend software, and then sending the data out to the bender, and then simulation of the correction process. I don't have a Unison bender here in the office, but I can simulate the correction process to demonstrate how that works. So what we're going to do first is, over at the bender, we're going to clear the data in the bender. So now we have all zeros. And before I import part data over at the bender, I know I'm going to need to know something about the tooling. So we're going to go ahead and clear this out in VTube-STEP, and we're going to import a step file, which is a neutral file format used by the solid modeling industry. And so I need to import a tube that we're going to set up on the bender. So I'm going to bring this tube in, and let me just press F5 and orbit a bit here. You can see it's just a simple tube end part. This is a pipe that is used in the shipbuilding industry, and I'm going to say add to the collected features because I need to collect the straights cylinders like this, and you can see we built up a collected features list over here. Now I'm going to rebuild the parametric tube data like this, and this is going to give us the capability of bending apart from the data that's in the model. We have the centerline XYZ coordinates, and over here we have the bender data, the LRA or the YBC data that can be sent out to the bender. So I'm going to go ahead and send this data straight out to the bender right now. And I'm going to go over to the bender now, and we're going to import this data. But before we import this data, I really want to set up the tool page. For example, right now the tooling is set to all zeros everywhere. So what I'm going to do is come in here and take a look at what tooling setup is necessary. I know this is a 1.315 inch diameter. It's a 1 inch nominal, but it's a pipe, so it's 1.315. And the default radius is going to be 5. You can see we're using 5 here on this bender. So let's go back over to the bender, and let's load in a part that is basically a setup part that has no data in it, except it has all of this tooling data already set. And I did this before I actually started this video so that you can see what it would be like, because we've already got the bender set up. The tooling's on, it's ready to go. In the tube menu, you can see we've got the diameter here. Now what I'm going to do is go into CMM, VTube measuring interface, and I'm going to read the file that VTube just created, which is this file right here in this path. Read the nominals. This is for bender setup, so we need to read the nominals. And I'm going to then exit out of here, and you can see we have new XYZ data. This XYZ data, for example, the first X is negative 1.750. It needs to match this, doesn't it? So it's the same data. It's just being sent over automatically, so you don't have to key it in, which saves us from the potential of problems by making mistakes in entry. I'm going to convert this data to YBC. These are not relative coordinates, so I'm going to say no. They're absolute coordinates. Look down here, we have 4.966, 8.536. You can cross-check this very easily because I've got both windows running on the same screen. Now what you do is bend the part using this data. Let's just assume that you're an operator that's familiar with this bender, so you know that we need an extra degree here. So you're going to go ahead and just put an extra degree in on the bend angle. So you're actually bending out 67.6, the bend arm itself. Okay, but you're trying to achieve 66.6. So what we're going to do now is we're going to bring the part back over here to VTube. We're going to switch to laser mode. We're going to connect to a measuring center, and then we're going to measure the part, and we're going to perform an alignment, and we're going to see the result in this screen. So what I'm going to do here, since we don't have an actual tube that came off a bender, I'm going to have to simulate the measured tube in an unusual way. I'm going to copy the master to the measured, and then I'm going to underbend this data so you can see it changed. Let's make this 178, 4.8, and 8.6, and 18. So it comes out slightly different. We're going to reverse calculate that by just moving out of that grid. And then what I'm going to do is perform an alignment, just because I need to do what I would do if I had measured this part. So I measured the part, brought it back over to the measuring center, and now we're going to align the measured data. And you can see that the pink tube is the measured aligned, and it's out of our tolerance. Right now this tolerance is 39 thou, which is probably too tight. So let's just make it more reasonable for shipbuilding, because this is a pipe for shipbuilding. Alright, so now we have a part that is partially in tolerance in the shape down here, the tangent midpoint tangent data, and almost in tolerance for the end lengths. It's a little bit out here. It's short for the first leg, long for the last leg. And if I were to orbit around here a bit and show you, you can see that it is short. The pink is short by that much, 154. And it is coming out of tolerance right here on the first straight. And someone may say, well, how much is that? And it's 107 thou. So it's slightly out of tolerance. What we need to do is correct the bender in order to bend the correct tube shape that follows this envelope. So we go into what's called bender setup, because we have a connection now to our bender. And in bender setup, what we're going to do is perform a recall, because we're going to assume that the user has made changes in order to bend the first part. So it's not going to necessarily be the perfect nominal data. But before we do a recall, we're going to do a recall in VTube. We're going to have to go into the CMM VTube measuring interface menu like this. So now Unison software knows that it needs to be ready to answer if I ask for the data. So I'm going to do a recall, and you're going to see the blue columns update, and it's suggesting that we change the part name, which I'm going to say yes please, do that. It's bringing in the diameter of the wall, the cut length from the bender. And now it says we need to correct by this much the lengths, and this much the rotation, and this much for the bend angle. So we have the before lengths, after, before rotations, after correction, before angles, bend angles, after correction, bend angles. So I'm going to send this data over to the bender. Correction damping's on. That would cut our corrections down. I don't want to do that. I want to let it have a full correction. So let's do that. And go over to the Unison bender, and we're going to read the data in. I just updated this file, and you're going to see data over here like 5.132. It should match this in the orange column, 8474. I'm going to go ahead and apply the changes, and now you're going to see the data in the brown boxes, which is representative of the correction data, change. So now you bend this new part with this correction data, and you bring the part back over to the measuring center, VTube-LASER, and then you hopefully will get more green over here. So it might look more like, let me just do this data handling, copied, master to measured again. And again, this is just a simulation, 66.5.4. It might still be off slightly, but it's very slightly. Let's see here, negative 180.1. And so we're going to go ahead and reverse calc that again. And we're going to perform an inspection alignment. And now the question is the part inside the tolerance envelope? And you can see in this case, It is. Now, obviously, I just simulated the correction, but you get the idea because you can see that the data is showing us that the pink tube is inside the tolerance envelopes. You can see that it's inside the lengths, and it's inside the shape data, the tangent, midpoint, tangent. Now, if anybody says, for example, what is the deviation at a certain point along the tube or the pipe here, then we could just zoom in on that section. For example, this is straight 2. What I'm going to do is I'm going to come out here and I'm going to hit Control-T to turn the transparency on. And someone says, well, what is the straight 2 tangent 2 deviation? And I'll show it to you. I can show you it visually, and I can tell it to you numerically, 0.014 inches. I'm going to push F3 to zoom all. I'm going to turn off the transparency with Control-T. And at this point, we don't need to go back out and correct the bender anymore. But there are still going to be some adjustments, always. But we don't need to correct the bender because the tube falls well within the tolerance envelope. It is very qualified in this application. And this is probably a little tighter than you would normally get on the first correction, but I would say you might get something that is around double this, depending on your setup, how good your setup is, and how new and how well your bender bends. In this case, for a Unison bender, it'll bend really well first time when it comes to correction. They're very good at correction. You're going to see data that comes well into the green very quickly. And in this case, of course, we're way under tolerance. So that's how easy it is to use VTube-STEP and VTube-LASER to import a part from a solid model and then export that part out to a bender and run through what's called the corrections loop. If you have any questions at all about any of what you've seen here today, please feel free to email me, Michael Cohn, at michael.cohn@advancedtubular.com. Thanks for taking the time to watch this video. Have a great day.